Hey, hello everybody. Now today we are going to be doing our week 1 day 3, our complex fractions. And for complex fractions, there is actually a few things that we need to take note, and I'm going to be going through our table of content. So we can see over here that we actually have our simplification of fractions that we need to understand. It's a simple process, but we need to just have a quick recap on this. But we also have our telescoping series, which probably will pose one of the bigger problems for many students out there. And later on, as usual, we have a practice question. So for the simplification of fractions, we need to understand that we can always do a cancellation of your common numerators and denominators so that we can simplify fractions and make it easier to solve. So something like this. A fraction that may look a bit complicated, but once we see some common numerators and denominators, we can do some cancellations here to actually make the calculation much faster. Because multiplying by 11, then subsequently dividing by 11 gives you the value of 1. So we can see only left with one numerator, one denominator, much easier to solve. But now it gets a bit more complicated because we can also use another technique as well, which is to factorize out some common parts. So as you can see here, the fractions may look a little bit easy if you were to try to solve it like that. But once you notice the numbers here, maybe trying to go and simplify the fractions individually, then combining them may prove a little bit difficult. However, do you notice something there is common between them? Let's say if we look at the numbers from the left side fraction, the numerators, and the right side fraction, the denominator, we actually see 1, 0, 0, 1. This means that we can actually factorize out a certain number. If we factorize out 1, 0, 0, 1, we're going to get 1 plus 2, and later on divide by 10. And from here times 21, and we get 7,007, but you can take away another 1, 0, 0, 1, factorize it out, and we notice suddenly something is common between our numerators and denominators across the fractions. So we can do again our simple cancellation, and we can see furthermore, this 21 and 7 can be further simplified. We can get your 3 and 1. And just like that, we are only left with the numbers at the top, numbers at the bottom. It's going to give us 9 over 10. So always consider actually using this factorization method here to go and simplify your fractions. Whenever you simplify your fractions, it gets much easier later on. But there is another thing to take note. Sometimes your fractions could be a little bit complicated. So sometimes your complex fractions can be very, very long, but we want to go and shrink it. We can call this the telescoping series. So just like a telescope, when you want to pull it out, it can be very long, but at the same time, when you want to keep it, you can shorten it. So this, in this case here, is our method on trying to go and shorten the fractions. So as you can see here, these fractions look a little bit like we cannot really combine them together. However, once we have enough practice and once you learn the general formula later on, you will get to see this is actually quite an easy question. Because as you can see the values over here, we can actually rewrite each of these fractions as such. 1 over 1 minus 1 over 2. It does give us half. Then 1 over 2 minus 1 over 3. This works as well. And we continue on so on and so forth until the last one. And we notice something. There are certain fractions here that we can cut. You can simplify by cancellation, 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 leaving us with only just 1 over 1 minus 1 over 6. And we suddenly have the answer, 5 over 6. Now, it may get a little tougher, like the one inside my next slide here. So the numbers here, you can see the denominators, the gaps are a little bit bigger now. But here, don't worry, let me show you now. So we use the general formula here in this case, and we will observe this value. We get your, when we were to split this fraction, what do we get here? We will get this. We get 3 minus 1 over 1 times 3. Then subsequently, 5 minus 3 over 3 times 5. 7 minus 5 over 5 times 7. And so on and so forth, all the way to our last term, 21 minus 19 over your 19 times 21. Now, in this case over here, you'll be wondering, wait a minute, teacher, I thought your numerator in this case is 1. How did it suddenly become 2? Never mind. I will show you first how we make it the same as your 1, but later on, we'll explain to you why you should be doing so in your next slide. So for now, we're just going to be multiplying by half across this entire formula. So that in this case here, once we try to expand it out, we will get this. Half 3, 1 times 3 minus 1 over 1 times 3 plus 5 over 3 times 5 minus 3 over 3 times 5, so on and so forth, all the way to the last term. 21, 19 times 21 minus 19, 19 times 21. So as we can see here, after doing some simplifications again, by doing some cancellations, cancel, cancel, then after that we cancel, 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 cancel. Look at what we get at the end first. Half 1 over 1 minus 1 over 3 plus 1 over 3 minus 1 over 5. And so on and so forth, all the way to the end again. 1 over 19 minus 1 over 21. And it is again very similar to our previous question. And this is the reason why we actually want our numerators in this case to be 2, because it's the gap between our denominators. Then we want to extract out the value so that we can still match the question with all the 1s in the numerators. So as usual, cancel, 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 cancel. At the end, we are only going to be left with half of 1 minus 1 over 21, which will then give us the value of 10 over 21. So let's see the general formula and how we're supposed to obtain these values now. Using the similar fractions that we have from our previous portions, let us view the general formula. Basically, you have your 1 times b, but your 1 times b can be split into this. We focus on the right side first, this b minus a. Basically, finding the difference between our denominator numbers. Your 7 and 3, we can plop it in. 7 minus 3, we get 4. So this means that your fraction on the left-hand side, we have to counter by dividing it by 4. Okay, and we continue on. And why does this formula work? Let's do some expansion here. We will get our next point here. We expand the ones inside, we get b over a times b minus a over a times b, and we cancel out again your common terms. What are you left with in the end? You're left with 1 over b minus a multiplied by 1 over a minus 1 over b. If we continue on with more and more and more of these terms, you notice you start to get your telescoping series from early on and some cancellations. So this is actually how you can use the general formula to assist you. And I would say it's going to be very helpful for you for your DMD later. Now, we go through one more practice questions to really understand how you can apply your telescoping series inside this question. The value of the arithmetic expression 1 minus 1 over 2 square times 1 minus 1 over 3 square, so on and so forth. Now, what's written as an irreducible fraction? What is the sum of the numerator and denominator of this fraction? Now, in this case, some students may be wondering, teacher, I need to use the square numbers here. Yes, you can. There is a more, algebraic method of solving this question, but I'll show you. Actually, without it, we can still solve. But of course, we need to observe a little bit of a pattern here. So now using this series over here, I'm going to write it in a different manner because I don't want to write it in this. I don't want to write as a 1 minus 1 over 2 squared. I only want to just have an individual fraction inside. You would see why. Because when I take 1 minus 1 over 2 square, I want to rewrite it as this. 2 square over 2 square, giving us the 1 minus 1 over 2 square. And in this case, look at the numerators. I can now rewrite my fraction as 2 square minus 1 over 2 square times, okay, multiplied by your next pattern. Okay, we have your 3 square minus 1 over 3 square times 4 square minus 1 over 4 square, and so on and so forth. we have many terms. Then after that, we get your 2001 square minus 1 over 2001 squared. But I am going to be writing it in a slightly different manner. Maybe you would observe, because if we get our values over here, we can get the value of, okay, let me write down the side over here first. Here, 8, this one, 15, this one, we're going to get your, we get the 3, 8, then 15. And do you notice there is a certain pattern that we can observe with these numbers? Okay, if you're not sure, never mind. Let me review the pattern to you. Because 3 is the same as 1 times 3. 8 is the same as 2 times 4. Just based on this pattern, you probably can tell me, teacher is going to give me a 3 times 5 for your 15. Very good. And our denominator, now I'm going to rewrite it in this manner here. 2 times 2, 3 times 3, 4 times 4, so on and so forth. And if we continue on, I'm going to bring in a few more of the patterns at the back, so it's easier for us to observe in a little bit. I'm going to get, in this case here is going, our final term is going to give us 2002 times 2000 over 2001 times 2001. Going one pattern back here, we're going to get 2001 times 1999. 1999 divided by your 2000 times your 2000. And after that, the term before that again, 2000 times 1998 over your 1999 times 1999. I'm only bringing a few more patterns over here, so it's easier for us to observe what I am trying to do. So as we can see here, we start to do some cancellation again. Use what you have learned in the earlier parts to go and do some cancellations. Let's look at your 3. 3. Ooh, can cancel. 3. Even more cancellations. And we look at the number 2 as well. I'm going to do a specific cancellation. This one, 2. 4. So on and so forth. Even on my right-hand side, I can do the exact same thing as well. As you can see, the numbers here, 2000, okay, 2000. And even more so, your 1999, your 2001, okay, so on and so forth. Sorry, let me make a slight change here. Let me go and cancel the other 2001. So it's going to be a little easier for us to see later. As you can see, these values here, these values will continue to cancel with the things at the front. And these values at the back here will continue to cancel with the things at the back as well. What we're going to be left with in the end is only going to be our first fraction and the second fraction behind, making it much easier for us to observe. Half times your 2002 over 2001, and we simplify it to 1001 over 2001. But again, take note of what the question stated. Sum of numerator and denominator. So we are going to take 1001 plus 2001, giving us 3002 as our final answer. So you can see, again, telescoping series, maybe not the way that we have done in the 1 over A minus 1 over B, but still a very similar cancellation method over here. So we can shrink from a very long calculation to a much shorter one. And one last thing to tell everybody. So our daily math doses, once again, please remember that there are 3 questions that will be sent out. Please try all 3 of them. And later on, send your answers inside the group chat. I can see there are some of you that are sending as a personal message, but please try to send it in the group chat so it's easier for us to observe and mark it for you as well. And last but not least, take note of the solutions that are sent out inside the group chats as well. You can see we just sent one yesterday. If you have not seen it, please go back and take a look at it. And that's all for today's DMD. Please be prepared. Okay, our questions are going to be sent out very soon.